Greetings, everyone. This is Mr. Anderson here. We're talking today in Learning Target W about arithmetic series. An arithmetic series is something that we already should have, I think, a pretty good foundation for because we've talked about arithmetic sequences. When I say that, I'm referring to the fact that an arithmetic series is simply the term that you get when you add up a certain number of terms from an arithmetic sequence. The language that we use, or the notation that we use when we talk about an arithmetic series, is S sub n. S standing for sum that we're getting for, or that we're using for the fact that we're adding. In the key concept box here, we have a formula for the sum of our finite. Just means it has no, a specified endpoint. If it was infinite, we couldn't find the sum, but the finite arithmetic series, and this is an important formula. It's one that we're going to want to stay well acquainted with. It says the sum of the first n terms, S sub n, right? S for sum, n indicating that we're taking the sum of n terms, is equal to n times the first term plus the last term, or the nth term, all divided by 2, or the average of the first and the last. All right? We're going to go ahead and we're going to put this into play real quick here in example number 5 in the study guide, and I believe this is on page 16 of the study guide. I'm not 100% sure. Oh, shoot, I deleted some stuff, so it's on page 2 for me. I believe it's on 16. Nope, I lied. I think it is on page 2 for you. In either case, hopefully it's not too hard to find. We're looking at example 5. Example 5 is really pretty easy to do if you recognize what you're being asked to find. We want to find the sum of all of these terms. Well, important to know a couple things. We want to know the first term, and I like to write that thing down first. So the first term, a sub 1, that is simply 5. The last term, though, in the sequence is 32, and that's pretty easy to spot here because there's no comma, there's no ellipsis after this. That is as far as we're going. But I don't know what term number that is, so I got to do a little bit of math to figure that out. How do I do that? Well, I use the sequence formula from Learning Target V, and that is simply going to tell me, well, a sub n is equal to a sub 1 plus the common difference times n minus 1. All right, now I can build an equation here, and I can use it to solve for n and figure out what term number is 32. So 32 is equal to the first term plus the common difference. Now, what are we going up and down by here? If I go from 5 to 8, and 8 to 11, and 11 to 14, I'm counting up by 3 every single time. So 3 times n minus 1. Now I need to distribute and combine some like terms. Okay, 32 is equal to 5 plus 3n minus 3. If I simplify, 2 plus 3n. I subtract 2 from both sides, I get 30 equals 3n. I divide by 3, and I get n is equal to 10. So I know that 32 is that 10th term. So the next thing I'm going to write here is a sub 10 is 32. All right, and then the last thing I like to write is, because this is the 10th term, I am going to be finding the sum of the first 10 terms. So I'll just put on there that n is equal to 10. Now, the sum of the first 10 terms is equal to 10 times 5 plus 32 divided by 2. And if you're going to go ahead and use a calculator on this, you just need to make sure you are adding first. And what I mean by that is this computation in the numerator needs to be done first. So if you're going to use a calculator, make sure you put an extra set of parentheses. Otherwise, just do this. 5 and 32 make 37, and then divide that by 2. All right. 10 times 37 is 370. 370 divided by 2 is 185. So the sum of the first 10 terms is equal to 185. Ladies and gentlemen, why don't you go ahead and tackle part B on your own. What we're going to do is we're going to jump down the page a little bit and talk about summation notation. Summation notation is something that looks a little bit intimidating. It's called summation notation because it has us doing the exact same thing, but using a different notation to get that sum or the summation. We do use the Greek letter sigma. This is a capital sigma from the Greek alphabet. We are always given our index variable. In this case, we're using I, but the index gives us the start. And on the top of the sum, or the summation, is the end point. How far are we going? In the last problem, we went up to 10. In the next one, we're going to go up a little bit past that. And then lastly, out in front, or to the right of the sigma, is going to be our index formula. Now, it's not just going to be exclusively I. Very often, as we're going to see in this first one, it's going to be a little bit more complex. So what we're going to do here in part C is we're going to tackle this the exact same way. We just got to pull the information a bit differently. So real quick, I invite you to look at part C with me. And part C says, if I'm reading this correctly, take the sum from the first term to the 15th term. So right away, I know that I'm taking the sum of the first 15 terms. I'm just going to mark down that n's 15. The next thing I need to do is I need to use my index formula in order to get that first and the 15th term. Well, how am I going to do that? I'm going to plug in 115 for I. So a sub 1 is going to equal 9 plus 3 times 1. Now this is something I can do in my head. All right, 9 plus 3 times 1, 3 times 1 is 3, 9 plus 3 is 12. So the first term is 12. The 15th term may be a little bit more difficult to calculate, is what happens when I plug in 15 for I. 9 plus 3 times 15. 3 times 15 is 45, 9 plus 45 is 54. All right, so the sum of the first 15 terms, or S sub 15, is equal to 15 times 12 the first term plus 54 the 15th term, all divided by 2. That 2 will always be on the bottom. That's never going to change. All right, I'll go ahead and work the math out here, and you simply get, remember to add 12 and 54 first if you're using a calculator, and then put that sum in. But if you do the math, you get the sum of the first 15 terms is 495. It's a pretty convenient formula, but I will remind you that if you wanted to, you could recognize that you have a common difference of 3. You're starting with 12 and you're going up by 3 every single time. So let me show you real quick. You could start with 12, go up by 3, the second term is going to be 15, and then 18, and you guys can see the pattern I got going on here. Then 24, and 27, and then 30, and then 33, 36, 39, 42, and 45, and then 48, and 51, and then 54. Now maybe, just maybe, you didn't like doing things this way. Maybe you'd rather write them all out and then add them all up. That's going to be fine too. This is just a much more, well, it's a much nicer way in using the formula, especially if I asked you to find the sum of the first 200 terms. It's much nicer that way. Okay, ladies and gentlemen, can I ask you to turn the page with me to the formulas that we have for special series here at the top of the page. These identify a couple commonly seen series and just a quick formula that we have. And these can all be derived using a little bit of math that's probably beyond the scope here, but check out what we got going on. We have the sum in example 5 of the first 32 terms, where the first term is 1 and the 32nd term is 32. So how do I know that? Well, check it out. Sum of the first 32 terms, right here, I'm going from 1 to 32, so I know outright that n is equal to 32. All right, the next thing I know is that my first term is a sub 1. Hey, that's going to be just 1. It's what happens when I plug in 1 for I, right? There's nothing being added or multiplied to that I. And then the last thing I know is my 32nd term. Whoops. The 32nd term, a sub 32, is 32. And like I said, I like to write these down. You don't have to, but the reason I like to do this is because it allows me to do two things. I can use any of these formulas up here, and you can see that this formula would work particularly well, but so would the one that we just got done using, and that's what I'm going to go with. It's the sum of the first 32 terms is equal to n 32, right, because there's 32 of them, times the first term plus the 32nd term, all divided by 2. And like I said, this works out well, and this formula is just because the formula plays off the fact that there's nothing being added or multiplied to any of the terms. The term is the same as the term number. So let's see, 32 divided by 2, so 16. 33 times 16, if I go ahead and work this out, I got a calculator here, you guys can't see it, but I type it into my calculator, I add the 1 and the 32 first, and I get 528. I think now is an appropriate time to pause the video if you need to, back up if you need to, and go ahead and get everything out of the notes that you need to, because the next thing we're going to move on to is at the bottom of this page. It's example number 6. So if you're ready, go ahead and move on to example number 6. You have a lot of time on your hands and decided to learn how to fold an origami pirate. Your goal is to fold 100. This should say pirates. If you want, you can make that change. If you don't want to, you don't have to. Given the complexity of the design, you really struggle with folding the first origami pirate. However, each successful origami pirate, after each successful origami pirate, you get 2 seconds faster due to experience. You've spent a total of 3 hours, which is 10,800 seconds folding. How long did it take you to fold the first pirate? So what we need to recognize here is what we're finding. There's some known information. We know that in this problem, n, the number of birds, is going to be 100, and we also know our common difference. If we're getting 2 seconds faster, notice that word is italicized, that means d is going to be -2. We're going down by 2 seconds each time. So what are we going to do here? Well, we're going to go ahead and use the arithmetic sequence formula in combination with the arithmetic sum formula to figure out our first term. Let me show you what I mean here. All right, I know a couple things about our arithmetic sequence formula. I know that a sub n is equal to a sub 1 plus d times n minus 1. All right, a sub n is not something that's known to me yet, right? So I'm going to go ahead and I'm going to plug in what I know. And wouldn't you know it, a sub 1 I don't know either, but I do know that my d is -2. So I'll go ahead and just insert -2 for d, and I know that n, because n's 100, n minus 1 is simply going to be 100 minus 1, or 99. And now I can do a little bit of mental math. 2 times 99, a sub n equals a sub 1 minus 198. Now check this out. I have one equation with 2 different variables. I can't solve this the way it is. However, I can use a second equation, and that second equation is what happens when I come up with the sum formula, or my arithmetic series formula. A sub n equals n times a sub 1 plus a sub n divided by 2. All right, now I know some of the stuff going on here. I was told I spent 10,800 seconds folding. That's how much total time I spent. That's equal to 100 divided by 2 times a sub 1 plus a sub 1 minus 198. Now check out what I did here. I went ahead and I plugged in a sub 1 minus 198 for a sub n. I took and I did a little substitution. If you want to add that to your notes, you definitely can. This stuff right here was directly substituted in for a sub n. And the second thing I did is I went ahead and I factored out the division by 2. All right, you can go ahead and write that on the inside or the outside. It doesn't matter because multiplication is commutative. All right, but then you go ahead and make the math a little simpler, I think, or at least attempt to. We got 10,800 equals 100 divided by 2 is 50. A sub 1 plus a sub 1 is 2 a sub 1, and that's minus 198. All right. Next step, I would go ahead, oops, let me close those parentheses. I'd go ahead and divide both sides by 50. And when I take and do that, 10,800 divided by 50 works out to be 216. And that's equal to 2a1 minus 198. Now I would add 198 to both sides. I got to scoot a little bit here to the right. I'd add 198 to both sides, and when I do that, I get, let's see, I'm using my calculator again, 216 and 198. That works out to be 414. That's going to equal 2a sub 1. And then I go ahead and divide both sides by 2. Trying to show this without running out of space here. And it looks like I'm going to. 414 divided by 2, that tells me a sub 1 is 207 seconds. All right, so the first pirate took me 207 seconds to fold. Okay, 207 seconds, that's almost 3.5 minutes, not quite. But then I need to figure out how long did it take me to fold the last pirate. Well, I got a nifty, really nifty little equation over here. That really nifty little equation is this guy. And that's going to tell me that if I plug in 207 for a sub 1, a sub n, or the 100th pirate, is going to equal 207 minus 198. And when I do that math, I get the 100th term is equal to 9 seconds. Okay, so the first bird took almost 3.5 minutes. I'm sorry, the first pirate took almost 3.5 minutes. The last pirate took 9 seconds. Ladies and gentlemen, what I'm going to do is I'm going to move on to the next example. Next example is example number 7. And I'm going to ask a couple of questions here, ask for a little bit of participation. Miss Tam loves her some student aids. She's found that since she began teaching at Park Center 8 years ago, she gets an average of 3 more student aid applications. If she's received a total of 108 student aid applications, how many did she receive the first year, and how many did she receive in her 9th year? So the first thing that I'm going to ask for a little bit of help with is identifying some of these unknowns. So take a second here, write down n. If you wrote down 9, you got it. The next thing I'm going to ask you to do is I'm going to ask you to write down the sum after 9 years. Okay, how many total student aid applications should you get after 9 years? Take a second, write that down. And then lastly, write down the common difference. So what does D work out to be? Okay, what is she going up or going down by? So if you wrote down that the sum was 108 and the common difference was 3, and the number of years, or the number of terms that we're dealing with is 9, then you're in great shape. We can do this the exact same way. We're going to set up the same formulas. We're going to set up a formula for a sub n, or a sub 9 in this case. That's going to be a sub 1 plus 3 times 9 minus 1, and I am going to go ahead and change this because this is a sub 9. Okay, and that means that the 9th term is going to be a sub 1 plus 3 times 9 minus 1. 9 minus 1 is 8. 3 times 8 is 24. So this is telling me that whatever she had the first year, however many student aids she had the first year, she added 24 to that in her 9th year, by her 9th year. Okay? Nextly, we're going to go ahead and use the sum formula, or the summation formula. So, ladies and gentlemen, S sub n is equal to n times a1 plus an over 2. All right? Like I said, I factored that out, that divided by 2 out last time, and if you want, you can do that here. This is the exact same formula. Some textbooks may have it written that way. All right, but let's go ahead and plug in some of the stuff that we know. We know that we were taking the sum of the first 9 years, and that's going to be equal to 9 over 2 times a1 and an. Well, a1, I don't know. That's what I got to solve for. And an, or a sub 9 in this case, is going to be a1 plus 24. And now I know that the sum of the first 9 years, 108, equals 4.9 over 2 is 4.5 times 2a1 plus 24. I'll go ahead and take and divide 1, oops, let me close that parentheses. I'll go ahead and take and divide 108 by 4.5, or divide both sides by 4.5, And again, I got this calculator. You can do it along with me. 108 divided by 4.5 is 24, and that's equal to 2a1 plus 24. Now this, I don't need to be a super strong mathematician to realize what's happening here. What I'm saying is that 2 times some number plus 24 is equal to 24. There's only one number I know of that allows that to happen, and that is 0. 2 times 0 plus 24 is the only thing that yields 24. So what is that telling me? That's telling me that her first year here at Park Center, Miss Tam did not have any student aid applications. But then how many did she have by her 9th year? Well, we're simply going to take and we're going to put in 0. So we'll say a sub 9 equals 0 plus 24. That means that by her 9th year, Miss Tam had 24 student aid applications. Ladies and gentlemen, thank you for your attention. Have a great day. You should be able to jump into the Learning Target W homework.